Welcome to the Drifter's Snowboard case, where we will end up building a database. First, we will illustrate an ER diagram that represents the Drifter's company. Second, we will show some create statements for the tables, the constraints, and the keys that support the Drifter's Snowboard company. We will show inserting data into each of the tables. And finally, we will do a few queries that support the Drifter's Snowboard Company. So I'm excited to get going. The Drifter's Snowboard Company is an online brick and mortar snowboard store. There are 3 snowboard styles, including the freestyle and freerider, which both retail between $800 and $1,200. The downhill style retails between $2,500 and $3,000. We note that Drifters marks up their snowboard 100% from its cost. So for example, if a downhill snowboard retails at $3,000, we know that Drifters paid $1,500 for it. Acceptable forms of payment for an order include the following credit cards: American Express, Discover, Visa, and MasterCard. An order can be paid immediately, or it can be paid with multiple payments to pay off the order. We note that Drifters advertises extensively at races and resorts during the ski season, so that's when they have their highest volume of sales. Orders are filled and the product is shipped either directly to the customer or they can pick it up at the retail location. Snowboards are ordered by selecting a model and a quantity of the snowboard. So if a customer ordered 3 identical snowboards, it would be the model number 1 and the quantity of 3. And the customer provides a credit card number and an expiration date for the payments. The customer receives confirmation of the order, an order number, the total amount charged to the credit card, and the estimated delivery date. Again, ordering can be done either online or in store. So armed with that entire case and knowledge of some of the business rules, we have a UML class diagram and that's going to include customers, and they have a relationship to orders. Orders have a many-to-many relationship with snowboard models, and that is known as an order item. So really, order items here is a bridge table between orders and snowboard models. So a given order might have 3 or 4 different snowboards and maybe even a quantity. Now a snowboard model is of a given style, and a snowboard model has a supplier. Now orders can be paid for in a single payment or a lot of payments. And a payment can be made with one of the credit cards. And we can see there at the bottom. The reason that this is a 0 to many is we might have placed an order, but we haven't got the payments yet, so we're allowing for that. So this is a UML class diagram, and that's going to be the blueprint for us to do the DDL or the create statements. After we have the ER diagram, or in this case the UML class diagram, the next step is to come up with the create statements for the tables that are described here on the UML class diagram. So the first table we want to look at is the customers table. And the relevant notions here for a customer are customer ID, first name, last name, address, city, state, zip code, country, phone, email, and we need to confirm yes or no whether or not it's correct. It has a primary key of customer ID. This item means that the primary key will be generated automatically by the DBMS. So an identity data type in SQL Server lets you have that be a system generated primary key. The 1,1 means it starts with the number 1 and it increments by 1. Another question that sometimes comes up is this brackets. When you have an attribute that is the same as a SQL Server reserved word, then it would show up as a different color, and sometimes that can cause problems. So address and state are both reserved words in SQL Server. Let's look at the suppliers table now. Again, supplier ID, supplier name, address, city, state, zip code, country, phone, web address, email, and the primary key is supplier ID. Once again, our primary key is a identity data type, so the values will be created by the system. The next table is styles, and we only have 3 attributes because we know that we just want a style ID and a name. It actually only has 2 attributes, style ID and name, and the primary key is style ID. Remember, there are only 3 rows in this for each of the 3 different styles. The next table that we'd create is the credit card IDs table, and it'll have a credit card ID, and there's only 4 rows again in this table. It's MasterCard, Discover, Visa, and American Express. So it would be maybe a 1, 2, 3, and a 4, and the name. Again, we have an identity data type. Orders has an order ID. Customer ID is, here's a foreign key, and down here that's specified. We have a date ordered, estimated delivery date, the total amount of the order. So if they ordered 5 different snowboards, then they would have to be totaled up to make that total order, and yes or no whether it's paid in full. The next table is payments. So you might have 10 payments to pay for a single order, especially if it's large. So we have a system generated payment ID, an order ID, which is a foreign key, and we noted that because in our ER diagram. We look back at our ER diagram then, we see here on payments that it has a relationship to orders. So we're trying to make our ER diagram and our create statements consistent one with another. Again, the credit card ID is also a foreign key because it's on a given credit card. So we have credit card ID as a foreign key, and we have order ID as a foreign key. Not last, but models table. Model ID, it's of a style, which is a foreign key. Supplier ID, which is a foreign key. The name of the model, the description, the cost, the price. We didn't put the rule here because we left some ability to have the designer to have flexibility, but we know that price is double what cost is from the description. The board size, and that's really board size in centimeters. So I might put that. I didn't. I just kept it easy. But it's nice to know what the unit of measure is. We have, again, primary key is model ID, and then a foreign key is style ID and supplier ID. Now we have the order items table. Let's get that scrolled up on the screen. And remember, order items is a bridge table between customers and orders. So we have an order ID, we have a foreign key of models. It's also connected to the models table. And we listed this time the primary key a little bit different way. This is more of the older ANSI style that you list the primary key up at the top of the table definition. We have a quantity, an extended price, something that's on back order, a delivery date, and again we have the two foreign key constraints. One of the last things that we want to do is look at the calculated columns and see if we can't automate those. So first, let's look at extended price on the order items. So extended price is a function of what the price is of the model times the quantity. So we're going to guess that model ID 1 is $800, and we come down here and we see this model ID number 3 has a quantity of 2. We're going to hope that that's $800 to make sure that that worked right. We come down to the models table, we look at price, and indeed the Bumblebee model ID 3 is indeed 800. Another thing that we want to automate would be the total order amount. And the total order amount is going to be the extended price added up for each line item. Now, order ID number 14 has more than a single line item. So let's go back and look and see that we have order 14 is going to be 800 plus 900 plus 800 plus 1200. So that total order amount should be $3,700. And indeed that's what it is. So the big question then is, how do we automate those? Now, if we're inside of a single table making a calculation, you can do a computed column. However, if the data is between two tables, like what we see here, then you have to do something else. And in our case, we're going to do triggers. First, we're going to make a view, and that view is going to take a total amount for each order ID. So we do create view, we're calling it order items to orders, and for each order ID, we're going to get a total of all the extended prices. Here's what that view looks like. I know it's tiny, but we look for each order ID, what's the total amount? So here for number 14, it's $3,700. Next, let's make our first trigger. And this trigger is going to make a calculation and insert, or it's going to update order items and calculate the extended price. So we give the trigger a name, we're updating the order items table, we set the extended price equal to quantity times price. We're doing a 3-table join here. Now a lot of people would look and say, well, of course you joined order items to models, because that's where the model ID is. We can grab the price and then we can set the extended price. But what's this inserted table? The inserted table is a table with a row in it, and it's the table that has the attempt to do the insert or the update. So if we're going to change perhaps the quantity from 2 to 3, that's in the inserted table. Because we only want to change one row at a time and not the entire table, we join the inserted table to the order items to the models. Lastly, we build another trigger to calculate the total order amount. We're going to join the orders table to the order items to orders view. Then we're going to set total order in the orders table equal to the total order amount, which again came from the view where that was calculated. So we're going to get a calculation for the total order, and for each row, that's going to make the change. So I hope that kind of understand that automating some of the calculations and putting those into the table is very useful, and it can save time and also have improved levels of integrity.